With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So let's see this question. In this question it is given, when a sample of ideal gas is changed from an initial state to a final state, various curves can be plotted for the process like PV curve, VT curve like this. For example, PV curve for a fixed amount of ideal gas at constant temperature is a rectangular hyperbola. VT curve for a fixed amount of an ideal gas at a constant volume is again a straight line. And like this, if the parameters are changed, the shapes of the graph will change. Now answer the following question. Which of the following graph is not possible for a fixed amount of ideal gas upon moving from initial state to A to final state B? Let's see this graph first. In the first graph, is it possible or not? We need to determine, is it possible or not for a fixed amount of ideal gas, right? So fixed amount of ideal gas means the number of moles will remain constant. Now in the first case, in the A case, here you can see that PV is constant here. PV is constant. And here you can see, so this is a graph at constant temperature. At constant temperature, this graph can be obtained at constant temperature. This graph can be obtained where PV will remain constant, right? Because N is already constant and T will be constant, so PV will remain constant. Now when you move from A to B, pressure will increase. Pressure increases here. Pressure increases on moving from A to B, right? So if you move from A to B, the pressure will increase, but what will happen? The value of 1 by P will decrease, as it is decreasing also. Value of 1 by P will decrease. So pressure increases, but the value of 1 by P decreases as we move from A to B, right? So the first graph is possible. Now let's see about the second graph. This was about the first graph. Now in the second graph, it is given that there is a linear increase in with pressure and volume. So this graph is also possible. This graph is possible if temperature increases continuously. So if temperature increases continuously, right? So let's write down. Now, so you can say that this graph is also possible. The graph between P and B is a straight line. It is also possible. And the area you can see very well. The area will give you the work done. So that we know. Now let's see the third graph. In the third graph, what is there? It is given that VT is constant. VT is constant. Is this graph possible or not? Let's check. So we know that T can be written as, we know PV is equals to nRT. So finally what you can write? You can write T as PV by NR. You can write this T as PV by NR. So let's substitute here. T will be PV by NR is equals to constant K. So from here what you can say that PV square is equals to nRK. Now N is constant, R is constant for a fixed mass. So PV square is equals to constant. So this is also a polytropic process. We know this is a process. We very well know that this is also a process that is called polytropic process. Polytropic process. So definitely we can say that this graph will also exist. This graph is also correct because it is an example of a polytropic process and it is moving from B to A, as you can see very well. So what will be the correct option? It was asked which of the following graph is not possible. So you will say that all the graphs are possible. So finally the correct option is none of these. So option 4 is correct, right? I hope you have understood. Thank you very much.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.